Welcome! In this series of short videos, we will look at topics for the PowerBasic Console Compiler. Today we will look at starting off a project using the Console Compiler. When developing PowerBasic applications, the very first question you should ask is, should I be using the PowerBasic Windows compiler or the PowerBasic Console Compiler? If you're going to be developing applications which use a graphical user interface, then you'll want to use the Windows compiler. However, one thing I've found in many years of coding in PowerBasic is that I have written many more console applications than I have Windows compiler applications. One of the reasons for this is there are many tasks which require no user interaction. These are applications which will run in the background and perform some task or service. The console compiler is ideal for these types of applications. They could be one-off applications, for example, reading through a large ASCII file and pulling information out of it. This is something you may only need to do once. Therefore, a quickly developed console application is ideal. Additionally, if you are required to write an application which performs some background task, for example, something that runs every hour or something that runs nightly, then there is no need for a user GUI, as everything can be written to a log file which can be interrogated by you later. So in this course, we're going to look specifically at the console compiler, what it is and what you can do with it. What we have on screen here is what we had in the last video. A very simple Hello World application. There are two things I'd like to cover initially. First of all is the technique of printing to the console. In the console compiler, if you don't declare otherwise, you will always get a console displayed. You may not require this once your code becomes production usable. However, for debugging and for developing, a console is very useful indeed. The print command will print something to the console. The command word print is the legacy approach to sending information to the console. Con.print is the more modern version. However, print will do quite nicely, or using the question mark instead of either conprint or print will perform the same action. If we run the application as it stands, we will get Hello World printed on our console. As we have used the wait key $ command, the application is now waiting for you to press some key on the keyboard, after which it gets to the end of the function and the application terminates. However, as your console applications are likely to be run unattended, you don't want to sit and wait for a user to press a key. Therefore, what we're going to do first is we're going to replace wait key with a short for next loop that will wait for 5 seconds and then allow the application to terminate. And we're going to create a small function to perform this. And we'll call this function exitApp. And here is our new exitApp function. We're declaring a local variable to allow us to count between the numbers 1 and 5. For each iteration of this loop, we are sleeping for 1000 milliseconds, basically 1 second. So in total, we will wait for 5 seconds and then exit the application. Since we're using a console in this application, it will be useful to give the user some kind of feedback of what is happening. So we're going to print to the console the words exiting application. We're putting a semicolon at the end of this string to ensure that the console will not move to a new line. And for each iteration of the loop, we're printing a dot out to the same line. So if we try running our application now, it will wait 5 seconds, and for each second it will print 1 dot to the screen, and then our application will terminate. This gives you a mechanism by which you can end your application, and the console will remain visible for 5 seconds before the application ends. We can add a little more flexibility in here and pass a parameter to this function, allowing it to wait for a variable length of time. let's say we want to keep the 5-second delay. We're going to pass our parameter in and we'll call that long delay. And it becomes the maximum of our for next loop. If we run our application once more, it will perform exactly the same function, only this time we're controlling how long the delay is. If we wish to wait longer, for example, 8 seconds, we merely have to change the parameter. And now we have an 8-second wait at the end of our application. So this is the first use of a common function. If you're going to be writing a lot of console applications, you may well want to use this function in every application. So what we're going to do now is we're going to create another tab on our IDE to allow us to create a common library. And we're going to save this as PB Common Console Functions. And we will cut this function out of our application, and we will paste it into our new library. And in order to access this code in this extra file, we're going to put an include command in. This instructs the console compiler to add this library in at the beginning of our code. And at compilation time, our new function will appear in the executable. So if we test compile that now, it compiles quite cleanly. And if we attempt to run it, and it will run just fine. As we've still got the 8-second time delay in, it will wait 8 seconds before terminating. Therefore, this is a very useful way of saving useful functions and subroutines into a common library, which you can then include in any console application you create from then on. So we've now created an application with an include file. By default, the console compiler will always generate a console at runtime. However, this is configurable. If you use the console off command, this will turn off the console. Having turned the console off, there will be no console commands sent to the console. Therefore, the application will basically be invisible. So what we're going to do is we will comment out our common code, and we will put a simple sleep command in for 10 seconds. This will mean the application will run, but it will not actually do anything. So if we run that application now, and we have a look to see what's running in memory, we can see demo1.exe is indeed running at the moment. It will wait for 10 seconds and then terminate. But as you can see, there has been no console visible to the user. So if you wish to create an application which runs in the background and is not visible to any user sitting in front of that computer, this is the way you can do it. However, it does make it a little difficult to debug your applications. So now that we've created the kernel of a console application, what else can we do? If you are running background applications, it's always very useful to create a log. At the very least, you can store in that log when the application started and when the application completed. Some background applications that you write may take a very long time to run, and knowing how long they take can give you a good idea of how performant your code is. So let's create a log file for our application. So what we have done here is we've created a local variable called log, this being a string variable. And we're populating that string variable with this inbuilt function to PowerBasic. exe.nameDollar will return the name of our executable. There are a number of extensions you saw here. There's name $, name $, and these perform slightly different functions. The exe name returns just the file name of the program which is currently executing. And $x on the end returns the name and the extension. So this is very useful where we want to create a common function to pull back the name of the file. And we're tacking on to the end of it underline log.txt. So now that we have the name of the file, we need to write to the file to say that our application has commenced. and we can create another common console function for this purpose. And as you could be writing many console applications, this new function to add to a log is something you will probably use a great deal. So let's put this in the Common Console Functions library. So here we are back in our Common Console Functions, and I've added a new function called append to a file. This function is going to take 3 parameters. The first parameter is going to be the file path which we wish to add to. This will specify the path and the name of the file, which in this case is going to be our log file. The next parameter is a string which is going to contain the data that we wish to write to the file. And the final parameter, which is going to be an output parameter, will be the text which contains an error message should an error have occurred. So our first task in this function is to work out whether the file we wish to write to already exists or not. In PowerBasic, we can do this quite easily by using the isFile function, which is inbuilt to PowerBasic. Given the path and the name of the file, it will return either true or false. If it returns true, then the file already exists. If it returns false, then the file does not exist. So we can then use an open command dependent on whether the file exists or not. If the file does exist, we're using the append option on open file. And we're putting a lock shared on it so we can write to the file. But this does not stop any other part of the application or any other application from reading the file. But they cannot write to it. Before we did that, we obtained the next available file handle. The file handle is a number that PowerBasic uses to recognize which file we're actually writing to by a unique number. The freeFile function will return the next available number. We're trapping all of this in a try-catch block. This allows us to add error handling very easily. So if the file already exists, we open to append to the end of that file. If the file does not exist, then we create a file and prepare to output to it. And then we're using the print statement to print information directly to the file. Note, this is a use of the word print, as in printing to a file as opposed to the console. And if that prints successfully, we return the value true to the calling function. If we have an error within this first part here, we're going to populate the error variable, which in this case is going to be an output variable, with error$, which is the text of the error that has just occurred. And then we return the value false to the calling function. And after that, we will close down the handle which designates the file we had just opened. Now, the one thing we have actually used here is we have used these two constants, true and false. Now, these have not yet been declared, so if we attempt to compile our application, it will complain that true has not been declared. The true and false are automatically declared in the Windows API include file, or we could declare them separately in here. As we may well be using some aspects of the Windows API, let's just include that at the beginning of the application. And there, our application now compiles quite happily. Before we go further, it's worth explaining a bit about include files. We know that the PB Common Console Functions include file exists in the folder that our application resides. We have not declared a path to that file, so PowerBasic assumes that it is in the folder with the rest of the code. However, the Windows 32 API include file does not exist within this folder. However, as you may remember from the last video, if we look up at the menu at the top and look at options, there is a compiler tab. And in the compiler tab, there is a path selection here. This tells us where the Windows API include files actually reside. So if PowerBasic doesn't have a path to an include file, it will first of all look in the folder which your application sits. If the file is not found there, it will then look through this list of paths to see if it can find an appropriate file in these folders. So the Windows 32 API does exist in this Win API folder. Therefore, it can be compiled quite easily within your application. So now that we've got the name of our file, let's write to the log. We can do that quite easily by just calling this function. This function will return a true or false. If it returns false, we can print out to our console that we are unable to write to the log. And if it does return true, we can write out to our console that the write to the log has been successful. So we need to give it its parameters. So we have a log name, we can put that in. We haven't specified a path in this, therefore it will write to the folder we're currently in, which is usually very useful. You can of course tack a path on to the beginning of this string. So the next parameter was the data we wish to write. So we'll write the string app started. And we will also pass our error variable, which we'll declare at the beginning of this function. And we can do the same at the end. Now we're going to assume if we get this far that the file does exist. And we're writing application ended. So if we do a test compile to make sure everything looks okay, and we attempt to run our application. So we're getting a write to log successful, and we're now exiting our application, and once this finishes, we should be able to look into our folder and see that we now have a demo1.log.txt file. If we open that up, we'll see we're getting app started and app ended. Now we may want to add on some times to this. So we can quite easily add those on by adding on time $, and we'll add this on here as well. Now if we are unable to write to the file, we may want to print out this error on the console by tacking it on to the end of this. So if we run our application once more, we should write to our log. Now it will append to the log that already exists. And if we have a look at that log, we should see our original text of the first run of the application and the new text, giving us the times. So we can see when it started and when it finished. You can, of course, add the date to this using date $. But you may want to create a new log every time the application runs. So what we can do here is we can test for the presence of that log and erase it when the application starts. So we can put this in a try-catch block and use the kill command to erase that log file. So if we run the application once more, we're writing to the log, we're exiting the application, and we're waiting for the application to complete. Once the application completes and we have a look in our folder, we can see there's our demo log, and the demo log no longer has the previous 2 runs of data within it. It only has what we've just run a moment ago. So if you wish to overwrite the log every time the application runs, this is the easy way to do it. So the final thing I'm going to do today is to create a project file. At the moment, we have 2 files in our project. We have the main file, the .bas file, and we have one include file. If we go into File, Save as Project, and we go back into the folder where our code sits, and in here we want to create a demo1 project file. And we have 2 options here. We can do it as PBP or PRJ. So we're going to go for the PRJ. And if we hit save. So now that we've saved that as a project file, let's just close down both of these windows and go into the open. So we go into the folder and change our drop down to show all files. We'll see there is a demo1.cc PRJ. If we double click on that, it will load both files. So if you had 5 or more files loaded, it would load all of them at one go, saving you a moment or 2 for loading up your project. So in summary, what we've achieved today is we have added two include files to our application. One being a Windows API include file, and the other being an include file of our own creation. This contains two functions which we're going to be using in future applications. One to exit the application, and one to append text to a file that already exists, or to create a new file and write data to it. This allows us to log data to a log file, saying when our application started and completed. And the exit of our application is performed by a function within our new library. This takes a parameter which allows you to set how long to wait before the application terminates. So this should have given you a structure to help you begin your application. We'll continue this in the next video, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.